Last couple days we've been looking at estimating square roots along with our number system. There's a different video on Google Classroom for that one. So let's kind of go back to the beginning. So when you square a number, that's asking the number, you're taking it to the second power, which means you're taking 3 times 3 in this case. So you're taking it multiply itself 2 times, which gives us 9. What's happening visually, I'm going to move this down here because it's kind of just getting in the way. What's happening is when you're squaring a number, you're physically going to, we're not going to actually draw the square, we never really do. But if I have a side length 3 and I need to make the actual geometric shape square, then we put a 3 on this side and we make a square that's the same distance on all 4 sides, and then the area of that square is 9. So that's why they call it squaring a number. You're physically making a square. What we're learning about right now is called the square root. The square root is the opposite of squaring. It looks like this. It's a square root symbol. They're called radicals. You may sometimes see it with a 2, even though most likely you won't. And then you'll have a number underneath, for in this case, 9. The square root of 9 is asking us to go from this and walk it backwards this way. So what number times itself twice? So you're like, what number here, and they have to be the exact same number, gives you 9. In this case, we get 3. So we're going to go through and we're going to make a list of all of our perfect squares so we have reference to them later. So I'm just going to make a quick table over here. So here's our x, and then we're going to take our x and square it. So 1. So 1 times 1 gives us 1. 2, so we're going to do 2 times 2. In this case, it's 4. 3, we just did this on the other side, is 9. 4, 5, 6, 7, 8, and 9. Let's just stop there for today. 4 is 16, 5 is 25, 6 is 36, 7 is 49, 8 is 64, 9 is 81. So if I were to take any number over here on the right-hand side, these are called perfect squares. Visually, it means that I could make a square. So in this case right here, I could have a square. It's a really terrible square. Come on, Carlisle, get it together. That's better. Where it's got side lengths of 2 and an area of 4. This one down here, I could have a square with its side length 7, and that would give you an area of 49. So they're perfect squares. It also means if I take any of the numbers over here and I put them in the radical, square root of 4, my answer would be 2. Square root of 49, my answer would be 7. So if I asked for the square root of 81, I'd want to know what number times itself gives us 81. The answer would be 9. But if you look at the list here, there's a lot of numbers that aren't included. Like 2 and 3 aren't included, 5, 6, 7, 8 aren't included. From here, that's 10, 11, 12, 13, 14, 15, 16. That's a lot of numbers that can't be perfect squares. No matter how hard you try, you can't have a square with area of 6 that has perfect side length dimensions. You could do 2 and 3, but then they're not the same. So we're going to learn a process to estimate them. Let's start with the square root of 6. So the square root of 6, it's not perfect. So what we're going to do is we're going to find two perfect squares to help us estimate it. So we're going to bring our little table here, 1, 2, 3, 4. So here we got 1, 4, 9, and 16. And I'm going to look for where does 6 fit over here on this right side of the table. So is 6 between 1 and 4? No. But it is between 4 and 9. So what I'm able to do is I'm able to make a number line that starts at the square root of 4, this number. It's going to end somewhere over here at square root of 9 because the square root of 6 is somewhere in between. So here's 4, 5, 6, 7, 8, 9. The reason why I didn't put 9 on there is because I wanted to know how far my number line actually was going to go. The square root of 9 is right there. I wanted it to be as evenly spaced as I possibly could make it. And then we're going to make a second number line. This is where we're going to get the estimation. I don't care about the square root of 4 because the square root of 4 is really just 2. Square root of 9 is really just 3. So that means any number in between square root of 4, here's 5, here's the square root of 6. It's going to be some decimal value between 2 and 3. So what I like to do to help estimate this decimal point right there is to add in a few decimals that I know for sure. So here's 2, the end has 3, right smack in the middle between 2 and 3 is 2.5. I then like to add in the halfway point between these two. That's a quarter of a distance, so that's 2.25. And a quarter of a distance over here, that's 2.75. By adding in those decimal points, it helps me hone in on where this point is right there. So it looks like it's going to be 2 points, so it's bigger than 2.25, less than 2.5. I'm going to say like 2.42 maybe. That's my approximate answer. I'm going to grab a calculator. I'm going to take the, where's my square root button? Okay, so that's how it works. I'm going to hit 6. I'm going to square root it. And here's the actual answer for the square root of 6. So it's 2.44. We're going to round it to 2.45. So the square root of 6 is approximately 2.45. We had a pretty dang good approximation, if I do say so myself, without using any other techniques than just some number lines. So let's try it again. Let's say we've got the square root of 12. So again, here's my perfect square list. 1, 2, 3, 4, 5. So we got 1, 4, 9, 16, 25. Turns out that 12 is right here between 9 and 16. So the square root of 9, square root of 16 is going to be over here somewhere. And I should be able to put the square root of 12 somewhere in the middle. So let's go make our number line. So here's 9, 10, 11, 12, 13, 14, 15, 16. So I didn't need any of this extra number line right there. So there's, whoa, geez. Don't want to take all of it, so I'm just going to erase that one and rewrite it. Here's the square root of 16. So I'm going to take the 12, so that's 9, 10, 11, so 12 is right there. I use my number line underneath. This is where we're going to actually get the decimal, because this isn't 12. This isn't anywhere remotely close to 12. I want to know the number that multiplies itself that gives you 12. It's some decimal value. So it's between 3 and 4. Here's 3.5, 3.25, 3.75, So according to my picture, it's another 3.45 kind of problem, 3.45-ish. That's my approximation. Let's see what the calculator says. 12 square rooted, 3.46. I was even closer on that one. Come down here. So the square root of 12 is roughly 3.46. Meaning if I were to make a perfect square, each side length would have to be 3.46 to have an area of 12. We're going to practice one more for this video here today, and let's make it a little bit larger one. Let's go, you know what, 34. 34. So here's our perfect square chart. 1, 4, 9, 16, 25, 36, 49. 34 is in between these two numbers right there, so the square root of 25 all the way over here to the square root of 36. So that's 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, so right about there. It's fine. Our number line underneath is now 5 and 6. Halfway is 5.5. That's roughly right there. 5.25, the quarter of the distance. 5.75, 3/4 of a distance. So we want 34. So that's 25, 26, 27, 28, 29, 30, 31, 32, 33. 34 is right here. Oh, straight down. I'm not going perfectly straight down. Right about there. So it's bigger than 5.75. So I'm thinking maybe 5.8, maybe 5.81 is the decimal approximation for that one. I check the calculator. 34 square rooted is 5.83. Pretty dang close approximations. So I know we have a calculator that can help us, but this skill is really helping us practice our number sense skill. What we should be able to accomplish by the end of this practice is that we can see that 34 is really close to 36. And if 36 is 6, then 34 should be a number that's pretty close to 6. That's estimating our square roots.